Okay, so we have just talked about how we can measure population change and what population distribution looks like. Now, we can also graph how a population grows, okay? So we're going to look at what are called growth models. These are growth models, and these are going to pop up all over the course this year, so it's really important that you keep these in mind. Okay, so here we have a graph showing our population on the y-axis and time on the x-axis. So time is going to increase this way, the population will increase this way. So over time, the population will increase. So the way a population grows will fall on one of two pathways. So we look at what's called a J-shaped curve. It looks just like a J. And an S-shaped curve. It looks just like an S. Okay? Now, this dotted line right here is what we call the carrying capacity. The carrying capacity is the amount that can be supported in one area. So, for example, a field, the specific size of a field can support 20 cows. Okay? Yellowstone National Park can support 10,000 deer, something like that. So the carrying capacity is the maximum amount of life that can be supported. Okay. Now, the way these two populations grow, they're going to interact with the carrying capacity. So you're going to see the populations shift in one of two ways. So let's look at our J-shaped curve first. So right here you can see by the very sharp slope of this line that this is growing incredibly fast. Okay? And what it's doing is it's going above the carrying capacity. So all of these individuals right here, they're probably going to die because there's not enough resources above this carrying capacity to support this population. So this is what we call exponential growth. Okay? This is exponential growth. Okay? And we say that it grows beyond the carrying capacity, which is not a good thing. Grows beyond, and I'm going to put K, all right? Carrying capacity is symbolized by a capital K. All right, it's just easier to write K than carrying capacity. So capital K, carrying capacity. All right, now our S-shaped curve, you can see that as it does start off slightly exponential, but then it starts to level off. And it never goes above the carrying capacity. So this population is obviously going to be much more sustainable, okay? So we call the S-curve logistic growth. All right, so logistic growth levels off. Okay, it's also sustainable. It's not going above the carrying capacity. Okay. Now, let's talk about some things that are common sense. So let's bring in these two graphs. So here we have our J curve. Okay. This is our J-shaped curve. Here is our S-shaped curve. Okay. So a J-shaped curve is what we call unrestricted growth. It just keeps going and going and going until it eventually crashes. And we'll look at what that looks like in just a second. Okay? So it accelerates. The logistic is restricted. It never exceeds our carrying capacity. Here's our carrying capacity, K. K for carrying capacity. Okay? So it slows down. All right. Now we know that the environment itself can limit population growth. It is all about the amount of resources available. If there aren't enough resources, then the population is obviously not going to grow. So, population growth is limited by environmental factors. So population growth is limited by environmental factors. And two of these factors are resources and space. Population growth is limited by environmental factors such as resources and space. That's common sense, right? Okay. Now, we say that resources can be limited because obviously we don't have an infinite supply of things. So resources are limited, and we call this finite. Finite's a fancy SAT word, okay? Finite means it's fixed. There's a certain amount. All right, so resources are limited and finite. So, when we see resources high, when resources are high, guess what our population is? You guessed it. Our population is high. When our resources are low, guess what? Our population is also low. You guessed that one too. Okay? Now, let's look at what happens to the population when it goes above our carrying capacity. Okay? So, here we have our J-shaped curve right here. Okay? As you can see right here, it has gone above our carrying capacity. K for carrying capacity. All right? Now, when it goes above the carrying capacity, we refer to it as an overshoot. Okay? An overshoot. An overshoot means a population has exceeded K. What's K again? Carrying capacity. So our population exceeds K. All right? Now, what happens immediately after it hits its peak? The population rapidly crashes, and we call it a die-off. Okay? So the die-off occurs because of resource depletion. There are no more resources available, so that's why we see massive death. Okay? So, resource depletion is obviously going to lead to mortality. Okay? Mortality is death. Leads to mortality. Okay? And it also decreases fecundity. Ooh, there's another fancy SAT word. It decreases fecundity. What is fecundity, you say? It is being fertile. The ability to have babies, which is what populations care about. Okay? So obviously, if you have an increase in mortality and a decrease in fertility, that is going to cause a population decline. Okay? Now, this catastrophic die-off is severe. Okay? So the die-off is severe. That is not a good S. Sorry, guys. The die-off is severe. Okay? So what this means is there's an extreme lack of resources. And what this does is it leads to famine, which hopefully you guys remember is lack of food. So famine, disease, and conflict. So there's going to be a lot more competition here. Okay? So this next picture is showing what can impact the population growth in an aquatic environment. It's basically the same thing. What resources are available? So here we have our, come on, where are you? Here you are. Here we have our carrying capacity. Remember our K, carrying capacity. All right. So what are things that are going to keep this population within reach of the carrying capacity or right below it? If you're a fish, obviously decreasing oxygen supply. If you don't have enough oxygen, you're going to die. Same thing with a land animal. Low food supply, you're going to die. Disease, you will die. Predation, you will die. Limited space, you will die. So all of these things are going to keep the population under control. Okay? So this is our second page of notes. Stay tuned for recording of part 3.